Ahoy, ahoy. This is the unit test review for lesson 3. I typically do not do test review work online. I normally leave that solely up to students to come to me with questions. However, there have been a lot of field trips and expeditions, and there's been a lot of my students that have been in and out. So I want to give them an opportunity not only to check their work online, but to have explanations for work they might have not understood or gotten wrong. So without further ado, let's get started. Number 1, a thumbtack is stuck to a bicycle tire. If the tire has a radius of 22 centimeters, sketch the height of the thumbtack above the ground as the tire rotates counterclockwise through 4 turns. Start your graph when the thumbtack is at the 3 o'clock position. Provide appropriate labels on the graph and write the equation of the graph. Seems like a lot going on here. First thing I'm going to do is I'm going to sketch because I like to draw things. Bang. There's my tire. I have a thumbtack in this tire. Okay? And keep in mind that it is starting at the 3 o'clock position, which is pretty much dead east. Okay? They say the radius is 22 centimeters. So this is the middle. Okay? The radius of my tire is 22 centimeters. All right? Now this tack is going to go around 4 revolutions, right? 1, 2, whatever. There we go, but it's going to start at 3. Now, they want us to sketch a graph of what this looks like. Okay, if I am starting here, if here's the midline where I'm starting here. That's the middle of the tire, right? I'm just going to extend this out. Okay, and I want to do a graph. I don't know, the ground would be right here, the pavement. All right, so let's draw a graph. Here's my y. Oh, wow, I got to change that. There. Here's my y-axis, okay? My x-axis is the ground. Okay? That's my x-axis. Okay? That's a height of 0. So that's 0 on the y-axis. This would be a height of 22, because it's 22 centimeters. All right? So my thumbtack, not only is it going to start 22 centimeters off the ground, it will reach a high point of another 22 centimeters above that. That is my high point. Oh, do I not have any more dashed lines? We'll just do yellow, I guess. This is going to be the high point. All right? And what is that? Well, 22 more than 22 would be 44. Okay? So my thumbtack, again, let's bring that out front. Order, bring to front, right there. Okay, my thumbtack, which starts right there, it's going to start here. So it's going to start right here. Then it's going to go up to 44, back to 22, down to 0, then back to 22. That's 1 revolution, and I want to do that 4 times. So it starts, okay, at 22. It goes up to 44. Okay, see, now it rotates up to 44. Then it comes back down to 22. Back down to 22, right there. Then my tack would come to 0. A height of 0 off the ground. Then it'll come right back to where it started at 22. This is 1 rotation, so I'm going to curve this, and that is absolutely a sine curve. Okay? Now, 1 rotation of a bicycle wheel around a circle is 360 degrees. Okay? Halfway point would be 180. Half of that would be 90, and this would be 270. But I got to do that 4 times, so they want me to graph it through 4 turns. All right? So let's just do what I did in red 3 more times, so that there will be a total of 4. It's going to start at 0. It's going to end at 0. Okay, in the middle. Then it goes up high and down low. It's a typical sine curve. Okay, there's a second one. I'm going to do it in blue. Starts at 0, ends at 0, in the middle 0, up, down. So I do another sine curve. Sine. Woo! Yay, sine. And then last one starts at 0, ends at 0, the middle 0. I come up, and I come down. And there's another sine curve. All right. So each one of these should end 360 degrees. So my sine curve in green goes out another 360 to 720. My blue sine curve goes out another 360 to 1080. And my yellow sine curve goes out another 360 degrees from 1080 to 1440. All right? That is perfect. That is the sketch they're asking us for. Sketch the height of the thumbtack. They want us to label the sides, okay? My axis. Obviously, the y-axis is height in centimeters of the tack. And my x-axis would be, I don't know, the turns or revolutions. Because this is turn 1, turn 2, turn 3, and turn 4. So it's turns in degrees, because we labeled it in degrees, right? 360 degrees would be one turn. Now, the last thing it's asking us to do is write the equation for what we just came up with. That's the easy part. Believe it or not, that's the easy part. I know I have amplitude, sine, frequency, x, plus whatever my midline is. We've been doing this for quite some time now. So my amplitude, my midline, that's the best place to start. My midline is 22. So I know I'm going to have plus 22. Well, what about my amplitude? I go up 22 to 44, and I go down 22 to 0. So my amplitude is also 22. I know my sine curve is positive because it goes up, then down. So the last thing I need is my frequency. Frequency, by definition, is how many curves are in 360 degrees. Here's 360 degrees. How many curves do I see? One curve in 360 degrees. So I can write my 1 here, but I don't have to. Okay? And that is the equation of our sketch. On to number 2. If a Ferris wheel with a diameter of 340 feet completes 3 turns and passengers board the Ferris wheel at the bottom, which is 4 feet above the ground. Okay, I want to start highlighting all important information here. Okay, Ferris wheel, a diameter of 340 feet, okay, completes 3 turns, okay, and passengers board the Ferris wheel at the bottom. The bottom is 4 feet above the ground, okay? Create a graph of a function that represents the height above the ground of the passenger car. Provide appropriate labels on the axis. We do not need to come up with an equation, but I always like to draw. Ferris wheel, center, okay? The diameter is 340 feet. That is 340 feet, which means what's the radius? Well, it's 170. But keep in mind that this Ferris wheel, okay, here's the ground, is 4 feet above the ground. Okay? And the ground is a height 0, obviously. We want our graph to be height above the ground. All right? So what I'm going to do is this. I am going to once again say, purple. Here's the ground. I'll do all these in purple. Here's my 0. Boom. Here's my midline. Boom. And here's my max point. The cart isn't going to go any higher than the top of the Ferris wheel. I hope you know that. Okay, so let's draw an axis right on here. Okay. There's my y-axis. There's my x-axis, okay? Where does my cart start? Well, the cart is going to start right there. That's my passenger cart. The cart is going to start 4 feet above the ground. It's not going to start at the ground at 0. You're not going to have to get, lay on the ground on your stomach to get into the cart. Okay? There's probably going to be a set of stairs right here. And you get in to your cart. Okay? So you are going to start at 4 feet above the ground. Your midpoint, this dashed line here, isn't 170. It's off the ground, the midpoint. It's 170 plus my 4. This is 174, the midline. And then the very top isn't 340. It's 340 plus the 4 feet. It's already off the ground. So that's 344. I hope you know that is height in feet. That is feet above the ground, okay? Height in feet. So I'm going to start my little cart here right at 4 feet. That's where I'm starting. All right. I am going to go to my midline next. Okay, go to my midline next. That's the next point. Then I go to my high point. Look at that. Then I go to my high point a little bit later. Then that's it. Then I come back to the midline. Back to the midline. Then I come right back where I started. Right down here. If that does not scream, okay, now keep in mind 4 is where we're starting, whatever. That does not scream cosine. That is an upside down cosine graph, right? It's a negative cosine. Bam, right there. Right? Through 3 turns, they want us to graph that. So I just graphed 1 turn. And 1 full rotation of a circle is 360 degrees. So I got to do this 2 more times because they want 3 of them. So I start down low, I end down low, and the middle is up high, and in between are my midline points. So there is my second curve. And that revolution is going to be another 360 degrees from 360. 720. And last but not least, I got to do my third one. Start down low, end down low, and the middle is way up high. And in between my high and low points are my midline points. Bam. And I go out another 360 from 720. There you go. And this is, rotation or turns in degrees. Okay. Okay. That's perfect. We follow. Okay. First turn, I'm following the blue curve. Okay. The midline to the top, back to the midline, down low. Then now I'm on the red one. So from the bottom to the midline, to the top, to the midline, to below. Now I go to the green curve, okay? The green curve. I'm down low. Then I go to my midline. Then I go to the top. Then I go to the midline again. Then I go back down. Okay? So we're really just following this pattern as we turn through our rotation. Okay, number 3, we don't have to graph anything anymore, which is a lot of work. Okay? An oscilloscope thing. It's a machine that changes sound waves into electric impulses and shows their graph on a monitor. One such graph can be represented by the equation A of t equals 12 sine of 2 pi over 15 t, where t represents time in seconds. What is the period of the function? Okay, I know I have amplitude, which is 12. But it's so hard to see when I circle things. Okay, I know I have amplitude and frequency, right? So I know my amplitude, I don't want the crayon. I have my amplitude, which is 12. I have my frequency, which is 2 pi over 15. Okay, but how do I get period? It's either 360 over frequency, or you can just say it's 2 pi over frequency. I'm going to use this one because they give me pi here. Okay? So my period is going to be 2 pi divided by frequency, which is 2 pi over 15. Now, what do I do when I divide by a fraction? I multiply by its reciprocal. I multiply my numerator by the reciprocal of this, by the flip. And the beautiful part there is, and this is why I use 2 pi, these cancel. And I end up with 15 is the period. Very, very simple if you know how to get period from an equation. Okay? On to number 4. What is the maximum value of the function f of x equals 12 minus 3 cosine of 3 pi over 2x? All right. I'm going to rewrite this so that you're more comfortable with this and you can understand better what I'm about to do. This is my midline. This is what I'm adding or subtracting. This is my amplitude. This is my frequency. I'm going to write this in the form that we're used to seeing it with my midline in the back. So I have f of x equals, this minus sign belongs to the 3, not the 12. So it's negative 3 cosine, 3 pi over 2x. This 12 is positive. Okay? Now, when they talk about the maximum value, they're talking about the high point. So how do I figure out the high point? I figure out what my midline is. The middle of my graph is going to be at 12, right? My amplitude is 3. That means I'm going up 3 and down 3. So I'm ultimately going to have a low point of 9 and a high point of 15. So if I have a cosine curve that's negative, it's going to do this, you know, whatever, which is beside the point because they're only asking me for the maximum value. And the maximum value that this graph is going to have is my amplitude going up from my midline, which is 15. So I have a max value of 15. Bam. Pretty simple. Question 5 is about more understanding sine and cosine than anything that would be on the final. But this is really good to drive home some just some knowledge that you should know and understand. Let's graph sine and cosine on this curve from 0 to 2 pi. In case you didn't know, 2 pi is 360 degrees, right? Pi is 180. Pi over 2 is 90. And this is 270. So it's nothing out of the norm. What I'm going to do, just for the sake of seeing this easier, I'm going to make my 1 up top and my -1 down low so we can really see the curves in all their glory. And here is 0. I'm not going to make this 1 and this -1 because it would be tough. I mean, not tough, but it wouldn't be as obvious as far as the curves go. So let's graph sine in red. Starts at 0, ends at 0, and in the middle is 0. In between those midline points, because sine is positive, I go up first, and then I go down, and I connect this. One sine curve. That is the sine of x. I will graph cosine in green. Cosine is the cup. Starts up high, and it ends up high. In the middle is where it's low. And in between those high and low points is where it touches the midline. At 90 and at 270. Okay? So, as I come through here, bam, that is cosine of x. All right. First off, they say for what values of x does sine equal cosine? Where do they touch? Where are they the same? Right here, which is nice. What's half of 90? 45. Okay. They also touch right here. What is halfway between 180 and 270? 225. So where are they the same? Well, at 45 degrees and at 225 degrees. All right. Now, what intervals are both Oh, both. I didn't write that on my thing. I just did them separately. But on what intervals are both y equals sine of x and cosine of x both positive? Both. So should I do them individually, or the interval where they are both positive? There's only one place where both are positive at the same time, and that's what intervals are both sine and cosine positive? All right. Well, let's do a highlighter for this. Okay. Cosine is positive here, and it's positive here. Anything above the x-axis, okay? Anything above the x-axis, this is where my y value, my sine and cosine curves are positive. This is where it's negative. All right? So what about sine? Where is sine positive? Sine is positive from here, here, and everywhere else it's negative. So what are the sections where they're both positive? They are both positive, okay? From 0 to 90 is the only point where both sine and cosine are positive. Isn't that the first quadrant? If I did all students take calculus, sine and cosine are both positive here. Sine is positive, cosine is negative. They're both negative here. And even though cosine is positive, sine is negative. The only place they're both positive is quadrant 1 from 0 to 90 degrees. That should make sense. From 0 to 90 degrees, they are both positive. So I would say from 0, when x is from 0 to 90, that's where they are both positive. Okay? Now let's take a look where they're both negative. Now I can look right here. The only quadrant in my unit circle where both sine and cosine are negative is quadrant 3. That's from 180 degrees to 270. Let's look at that on the graph. From 180 to 270. Well, I hate to erase this highlighter. Green. That is negative sine. Purple. Ooh, that's nice. I should have been doing it the whole time. This is negative cosine. Where are they both negative? Okay? Where are they both negative? Well, from this point, oh, wow, look at that go. From this point to this point, they're both negative. How come they're not negative here at 360? Because I see green where sine is negative, but look at cosine is positive there. Okay, I want them both to be negative from 180 to 270. Okay, from 180 to 270. That's where they are both negative all the time. If I go outside of that, one of them may be negative, but the other one is positive. All right. Let us do a review of tangent for number 6. Okay, we're going to graph tangent on the set of axis below here. All right. Tangent starts at 0. It's just like sine. It starts at 0. It ends at 0. And the middle is 0. Okay. I don't know. Let's call 1 right here and negative 1 right here, which it shouldn't matter. But I know, unlike sine, I don't have high and low points in between. That's where I have my asymptotes. Okay, these are lines that the graph is never going to touch. Okay, it's never going to touch. So, like sine, it's going to go up first. Okay, it's going to go up forever, up forever. It's going to go down forever, and down and to the left. Okay, that's exactly what tangent looks like, just like that. Boom! Congratulations. You did it, and I'm proud of you. There are no questions here. I think on the next slide there are. Okay, complete this chart based upon the graphs for tangent and sine. Well, what are the similarities? I just said it. Both start, end, and middle are on the midline. Okay, what are the differences? Okay, in between midline points, those 3 dots that we start with, Sine has a max and min. Tangent doesn't have a max and min. That tangent, that's where it has its asymptotes. Don't forget the P. Totes. All right? That's where it has its asymptotes. Those are the major similarities and differences. Those are the ones that you can really, if you know sine, you can graph tangent if you know, well, it's not where mins and maxes are, it's where the asymptotes are. All right? Number 8. Write an equation for each of the functions shown below. I like these. All right, so the first one, I'm looking at this. This is a cup, and it's open up. So I know it's going to be a positive cosine. I know I have my amplitude, cosine, my frequency, x, plus whatever my midline is. Okay, so where's the midline here? The midline is at 0. Okay, and the amplitude, I go up 1 and down 1. So my amplitude is 1, even though I don't have to write it. What's my frequency? My frequency, by definition, is the number of curves in 360 degrees. This is 360. How many cosine cups do I see here? I see 1. So that is 1x. And I could do plus 0 here at the end because my midline is 0. But we really don't write 0. I could do this, and it would be algebraically correct. But if this were multiple choice, I wouldn't write my 1s or my 0s. It would just look like that. Okay. Let's look at the next one. Same deal. Oh, it's a positive s, so I know it's going to be y equals something sine of x. And I have an amplitude and frequency. Here's my midline. Oh, my midline. My midline is 0, so I'm going to have sine of x. I have plus 0 in the back. My amplitude goes up 1 and down 1, so that's 1. And my frequency, how many sine curves in 360? I only see 1. So it's 1 sine of 1x plus 0. So it's really just going to be written like this, y equals sine of x. Finally, something different. Well, this is an S curve because, look, it starts going down, then up. So I know it's going to be a negative sine. My amplitude, my frequency, x, and plus my midline. Okay? So what is my amplitude? My midline is 0, so it's plus 0. My amplitude goes up 1 and down 1. My frequency. Here is 360 degrees. How many curves do I see? Well, I see my 1 here, okay? But then I see a second curve. There are 2 sine curves in 360 degrees. So when I write this, I'm going to say y equals negative sine. I don't have to write that 1 of 2x, and I don't have to write plus 0. I don't have to write plus 0. There you go, children. Filling in the chart with sine, cosine, and tangent of the given angles. I am going to first focus on 90-degree increments because those are the easiest ones to do. Okay? And I'm going to look at my graphs for this. I'm going to go back here. Let's look at sine. Okay? Sine at 0 degrees is 0. The sine at 360 is 0 on my y-axis. The sine at 180 is 0. The sine of 90 is 1. And the sine of 270 is negative 1. So I'm going to fill those y values in for that corresponding x values, okay? So it started at 0, it ended at 0, and in between at 180 degrees was 0. At 90, it went up to positive 1. At 270, it went down to negative 1. I'm going to do the same thing with cosine, all right? I'm going to go back. Okay, sorry about all this stuff. Now, I'm looking at cosine. Let's do this right now. Cosine, let's do highlight purple. Cosine is this one right here. Okay? Now, at 0 degrees, I'm at 1. for cosine. At 360 degrees, I'm also up high at 1. And at 180 degrees, I'm down low at -1. Okay? And in between that, at 90 and 270, that's when I'm at 0. All right? So I'm going to come back here and say cosine starts up high at 1, and it ends at 360 up high at 1. In the middle at 180 is its low point at -1. And in between at 92.70, that's when it hits my midline of 0. Now tangent is just sine over cosine. So I can literally make this fraction. 0 over 1 is 0. 1 over 0 is undefined. That's where an asymptote happens. It is undefined. It is not 0. 0 over -1 is 0. -1 over 0 is undefined. And 0 over 1 is 0. All right, that's good. But what about these 30, 45, and 60? Well, if you know your special triangles, and there are tricks and trades around these, but if you know your special triangles, you can fill in the rest of these. Let's draw our two special triangles. Okay, here's a 30, 60, 90. That is 1, radical 3, and 2. All right, so the sine of 30 degrees, its opposite over hypotenuse, it is 1 over 2. The cosine of 30 is adjacent over hypotenuse. So it is radical 3 over 2. And the tangent of 30 is opposite over adjacent. So it's 1 over radical 3, but we'll simplify that. We'll multiply the top and bottom by radical 3, right? So I get radical 3 over 3. So it is opposite over adjacent, which is radical 3 over 3. All right. Now let's do 60. Let's do 60 degrees. This is still radical 3, 1, and 2. So 60. The sine of 60 is opposite over hypotenuse. It is radical 3. Yeah, that's 45. I'll be okay. It's radical 3 over 2. The cosine is adjacent over hypotenuse. It's 1 over 2. And tangent is opposite over adjacent. So it's radical 3 over 1, which we will just call radical 3. Okay? Again, you can get the sine, cosine, and tangent of your 30, 60 angles by knowing your 30, 60, 90 triangle. What about 45, 45, 90? Okay. 45 degrees. It is 1, 1, radical 2. Sine is opposite over hypotenuse. 1 over radical 2. We are going to simplify that. We are going to multiply the top and bottom by radical 2. So I would get radical 2 over 2. Okay, so the sine of 45 is radical 2 over 2. What are the cosine of 45? It's adjacent over hypotenuse. It's the same thing. It's 1 over radical 2, which we simplify to say radical 2 over 2. And last but not least, tangent. It is opposite over adjacent. 1 over 1 is 1. Okay? On a final, if they ask you to do any of these things, you have a calculator, just type it in. Okay? But you really need to know these triangles moving forward, going on to pre-calculus and calculus. They are a tremendous, tremendous help. All right. Convert each of these degree measures to radian measure. The only way you convert degrees to radians, I take my degrees, put it over 180, reduce this fraction, whatever it is, and then just slap a pi on there. So, in case you didn't know, your calculator will reduce anything for you. So if I take 330 divided by 180, if I hit math, enter, enter, math, enter, enter, that's 11 over 6. So this was 11 over 6, slap a pi on it. 11/6 pi. Some ones we should know, some basic ones. 270 is 3 pi over 2, and 90 is pi over 2. Okay? If I take 225 and put it over 180, let's do the 225. 225 divided by 180. I hit math, enter, enter. That's 5/4. So this is 5/4 and slap a pi on it. Okay, sorry, this is pi over 2. I wrote it in the wrong box. Haha. 150, well, I mean, that's 5/6 if I reduce it. Okay, so 150 over 180. Cross out the zeros. And 3 goes into 15, 5. And 3 goes into 18, 6 times. I slap a pi in it. The last one is 315. 315 divided by 180. Math. Enter, enter. It's 7/4. Okay? So it is 7/4, and we slap a pi on it. That's relatively easy. That's good. And if you can convert back and forth between degrees to radians, that is going to be something special for you. We will do this last one, and we will stop here. And then I'll make another video for the the remainder of this review sheet. If I'm turning radians into degrees, just make pi equal to 180 and simplify. Meaning, 5 times pi, well, let's make pi 180. Over 6 and simplify. 6 goes into 180 30 times. 5 times 30 is 150 degrees. All right? Let's do the next one here. 2 times 180 is 360. 360 divided by 3 is 120. Okay, again, I did 2 times 180 divided by 3. 3 goes into 180 60 times. 2 times 60 is 120. What about this one? Pi is 180. So it's 180 divided by 3. Oh, that looks like 60 to me. Ooh, 11 pi over 6. It's 11 times 180 over 6. 6 goes into 180 30 times. 11 times 30 is 330 degrees. The next one, 3 pi over 4. It's 3 pi. Pi is 180 over 4. 4 goes into 180 45 times. If I multiply those, oh my God, that's 15, carry the 1. It's 12, 135. And last but not least, 8 pi over 9. 8 pi. Pi is 180 over 9. 9 goes into 180 20 times. 8 times 20 is 160. I mean, there you go. It doesn't get much simpler than that. We're going to end here. We're going to do problems 12 through 20 in a second video. And we have a test coming up. So, have at it. Good luck. And leave some messages if you have some questions. See ya.